everyone, welcome to my channel. So in the last video we discussed about the basics of chemical reactions and equations and some activities, and in this video we will be starting with representation of chemical reactions. Now before starting I want to clear one thing. Many of you might be facing a lot of difficulties in making reactions. You may not be very familiar with reactions. For example, if I ask you what happens when zinc reacts with sulfuric acid, so you may not be able to tell, but there's no need to worry. As we will progress in our journey of chemistry further, the things will become easier and easier for you all. So if you're not able to do it, don't worry. With time, you will do it in seconds. So now let's start our today's topic. Now first of all, why do we need to represent chemical reactions? Every time expressing the chemical reactions in the form of words will be very tedious. For example, if I have to say for this reaction like zinc reacts with sulfuric acid to give zinc sulfate and hydrogen gas. If I write it in words every time, then it will be very tedious and time consuming, and also it will be irritating. So to decrease our work, we have found out ways to represent chemical reactions. And what are those ways? The first one is word equations. So it represents a chemical reaction using the names of the substances involved, and there is a plus sign between the reactants as well as between the products, and the reactants and products are separated by an arrow. As you can see, this arrow is there, and this arrow also gives us the direction of reaction, means what is reacting to give what. Means you are reacting magnesium and oxygen and then you are getting magnesium oxide. So it has two components, one is reactant and the other one is product. So what are reactants? So the substances that undergo reaction, the substances which you have originally taken, the substances which were there initially with you, that is or that are known as reactants. Now what is a product? The new substance formed when you reacted the two initial substance or whatever it may be, the substance which is formed, that is known as the. Now let's see the second way. The second way is chemical equation. It is a symbolic representation of a chemical reaction. Now in this, instead of using words, you use the chemical formulas to make your work more easier, because even word equations might become tedious every time you have to just write the words. So now we decreased our work more further and we reduced it to formulas. Now chemical equations can be either skeletal or balanced. So what are skeletal chemical equations? So skeletal chemical equation is when your chemical reaction is written with the chemical formulas that represent each substance which takes part in the reaction, but no information is there about their quantity. For example, this way. Magnesium plus oxygen gives magnesium oxide. So it's giving information about what are the reactants and what is the product with their chemical formula, but no information is given about their quantity, means how many molecules of magnesium has been taken, how many molecules of oxygen has been taken, and what molecules of magnesium oxide you are getting. You are just being informed about the reactant and the product with their chemical formula. So such a chemical equation is known as a skeletal chemical equation. Now we can have a second type of representation in the chemical equations only, and that is a balanced chemical equation, and this is the more precise one, and we generally use the balanced chemical equations to represent a chemical reaction. So in this, along with the formulae of the reactants and products, we also indicate the number of moles or molecules of the reactants and products to make the reaction more precise and more clear, to make it complete. Okay, so the chemical equation in which the number of atoms of each element on the reactant side is equal to the number of atoms of each element on the product side. So it's not that you just put numbers randomly. No. There is a method to balance the chemical equation, and this we'll take up in our separate videos, how do we balance a chemical equation. But for now you should know what is a balanced chemical equation. Means the number of atoms of each element is equal to the number of atoms of each element on the product side, and this is necessary also. Let's see why is it necessary. I hope you all understood the meaning of balanced chemical equations. Means along with the information about the reactant and product, it will give information about the number of moles or molecules also, and not only that, but the correct number, not any random number. So now what is the need to balance the chemical equations? I hope you remember the law of conservation of mass which you studied in class 9. So it tells that mass can neither be destroyed nor be created in a chemical reaction. Means whatever you are taking, it will remain as such. It can transform itself, but it can neither be created nor be destroyed. So if you apply the same theory, then how can atoms be created or destroyed? If you are taking two atoms, you should get back two atoms, because atoms will not be destroyed or created in a chemical reaction, and that is what this law of conservation of mass also tells. And in order not to violate this law, we balance. Okay, if we'll not balance it, then it will lead to a misconception that how is it possible. So in order to be according to the law of conservation of mass, we balance it. Okay, and this is what is written over here. Now, along with the balancing, we can make the equations more informative, more precise, and more complete by telling about the state of reactants, so that one can come to know everything about the reaction by using the symbols for states and also indicating the temperature, pressure, or catalyst used in the reaction. For example, for gaseous, you use a small g. Aqueous, as I told you, aqueous is a solution of a substance in water. So for that you use AQ, for liquid L, and for solid S. Now we can also use an upward arrow for a gaseous substance and a downward arrow in case of a precipitate. We already discussed the precipitate in our previous lectures. Now reaction conditions, temperature, pressure, catalyst for the reaction are indicated above or below the arrow. Heat can also be indicated by a small triangle. So if an reaction is absorbing heat, then you can indicate that by putting a small triangle over the arrow. Or if it is evolving heat, then you can, along with the products, you can do plus a small triangle. So that will indicate that heat is being absorbed or evolved according to the situation. Now, what is a catalyst? We studied that we can indicate the temperature, pressure, catalyst, but what is a catalyst? So a substance that increases the rate of a chemical reaction without itself undergoing any permanent change. So it will help us to increase the rate of a chemical reaction, but it will not affect the reaction in any other way. It will just increase the rate of reaction. It may temporarily take part in the reaction, but after the final reaction, it may return back to its original state. So that is, it is written that it's not undergoing any permanent change. It may undergo change, but then it may return back to its original form, and it will just increase the rate of reaction and no other work. Okay. So now here are the examples of balanced equations, as well as how you can make it more informative. For example, 3Fe plus 4H2O gives Fe3O4 plus 4H2. And this reaction is very, very, very important. So you should keep it in mind that iron, when we'll deal with metals and non-metals, then we'll be more clear with this reaction that iron cannot react with water in liquid form. So it always reacts with water in steam, and that is why it evolves iron oxide in solid state. Okay. Then carbon monoxide in gaseous state reacts with two molecules of hydrogen gas at 340 atmospheric pressure to form methanol. So these may be very complicated for you all at the present moment, but as I told you, once we proceed, it will be very easy for you all. So you just need to revise them, and then you'll get it into your mind. Don't be afraid. Okay, with time you'll just do it. And this is the very common reaction of photosynthesis. You're aware of it. So over here also, chlorophyll and sunlight are taking part, but they are not influencing it. So are indicated above and below the arrow, and this is how we make the reactions more informative. So now, types of chemical reactions. The first type is combination reaction. It's very simple. If two or more reactants combine together to give a single product, mind it should be a single product, and then we'll call it as a combination reaction. Now the reactants can be anything. It can be two compounds, two elements, an element or a compound, any combination. But at last it should give a single product, and if that is happening, then we call it as a combination reaction. Now in your book there is an activity for this, activity 1.4. Let's discuss it. Take a small amount of calcium oxide or quicklime in a beaker, slowly add water to this. So what we are doing, we are preparing an aqueous solution of calcium oxide. Basically, we are reacting calcium oxide with water. Now what are the observations? As I told you, observations are very important. So there is vigorous bubbling. Why? Because it's an exothermic reaction. So heat is evolved, and that heat only causes vigorous bubbling, but we can take this as a separate observation that there is vigorous bubbling because this is what we saw, so we can write it as a separate observation. Hissing sound is produced when calcium oxide is reacting with water. Then the reaction is so rapid that hissing sound is also produced, and the reaction mixture becomes warm. Means you will touch it, then the reaction mixture will be warm. So these are the observations. Now what is the reaction? Calcium oxide in solid state is reacting with water in liquid form to form calcium hydroxide in aqueous state along with the evolution of heat. Now over here you need to remember that calcium oxide is also known as quicklime or lime. This is very important. You should remember it because at times they may not give you the direct name that calcium oxide, but they may use the name quicklime or lime, so you may be confused. Similarly, calcium hydroxide is known as slaked lime. So now you might be, confused how to remember which is quicklime and which is slaked lime. So when I studied, I devised a trick. And what was that trick? Like if you see the formula of calcium hydroxide, it's quite complicated. It's having brackets, then H is also there, 2 is also there. But calcium oxide is very simple. You can write it quickly. So that is how I remembered. Means it's short, so quick. So this is how I relate it. Quicklime, calcium oxide. And since it's complicated a bit, calcium hydroxide, so that is why it's slaked lime. Okay. Now this is given in your NCERT book in a box as did you know. So this is also important because they frame questions from here also. And what is it? That a solution of slaked lime produced by the reaction 1.4, the reaction we saw just now, is used for whitewashing walls. You might be very aware of what is whitewashing. You often, people often use it. So to give the shiny finish to the walls. So now in that, what happens is that the calcium hydroxide solution which we got from that reaction, when you're reacting calcium oxide with water, you get calcium hydroxide. So now this solution is used to whitewash the walls. How? We apply a coat of calcium hydroxide on the walls, and after few days, what happens? This calcium hydroxide reacts with the carbon dioxide in atmosphere to form calcium carbonate. As you can see in the reaction, it is reacting with CO2 gas to form calcium carbonate, and it's also forming water. But the main reaction is that it is giving calcium carbonate, and this calcium carbonate only gives a shiny finish to the walls, and this is how the walls are whitewashed. Now we have some examples of combination reactions over here. For example, burning of coal. If you're burning coal, then when you're burning anything, then they generally combine with the oxygen of the air. So at times they may give you to form an equation for burning of a substance XYZ. So always remember that when you're burning a substance combines with oxygen. So you should not forget that burning will lead to combination with oxygen. Okay, so when coal is burning, so coal is what? It's a form of carbon only. It has carbon, so we'll take it as carbon is reacting with oxygen to form carbon dioxide gas. Now formation of water from H2 and O2. It's a very common reaction. Hydrogen and oxygen gas react together to form water. Now endothermic and exothermic, though we have already discussed them several times, but still we can study them as a separate topic. That endothermic reactions are those reactions in which heat energy is absorbed, means you're taking the heat energy from the surroundings, and the result is that the reaction mixture's temperature will fall after the reaction. If heat is being absorbed, then as a result the reaction mixture will become cold. For example, we already discussed this example, but doesn't matter, we can discuss it again. Barium hydroxide will react with ammonium chloride to give barium chloride plus ammonia gas. NH3 is ammonia and water. Now this reaction is characterized by a fall of temperature, which means that it is an endothermic reaction, and this reaction is given as a question in one of your activities. Heat energy is absorbed during this reaction, to which the temperature of the reaction mixture falls and the bottom of the test tube becomes cold. Exothermic reaction. So the reactions in which the heat energy is evolved along with the formation of products, that is known as an exothermic chemical reaction. Means heat will be given out. The end result will be that reaction mixture will become hot. There will be a rise in the temperature. So what are the examples? Burning of natural gas. CH4. CH4 is methane, and it is reacting with oxygen. Again, it is burning, so it will react with oxygen to form carbon dioxide and water. Respiration. This is a very common reaction that glucose combines with oxygen to give carbon dioxide plus water, plus a lot of energy is given out. Since energy is being liberated or being evolved, we'll call it as and exothermic reaction. Now, the decomposition of vegetable matter into compost is also an example of exothermic reaction. Okay, so if the decomposers are reacting with the dead and decaying organic matter and they are decomposing it, so that will be an exothermic reaction. You need to remember this. Okay, so yes, this was all for today's video. We'll continue with other types of reactions in our next videos. Hope this video helps. Also, you can get the complete notes for this chapter just rupees 30. You can DM me for details. And please don't forget to like, share and subscribe to my channel. And hit the bell icon to get all the notifications from Learn Merrily. Thank you. Bye.